Think your mains powered smoke alarms will last forever? Think again. Today we're replacing expired alarms and expanding the system with extra protection, both wired and wireless. And yes, we've even got a trick to stop you falling through the loft. I've not long moved into this new build property and it's really nice to be somewhere a bit more up to date than the old place. However, not all is as peachy as it seems. One of the first jobs that I've decided to do is to replace the existing hardwired smoke alarms, which raises the very reasonable question, why? Well, first of all, let me say there's nothing wrong with these existing smokes as a product. This isn't about one brand over another, but it is recommended that all smoke alarms are replaced after, at the most, 10 years and sooner if they should fail for any reason. And while this property is very much classed as a new build, it's actually about 11 years old, meaning that these smokes are actually overdue for a replacement. And just in case you think I'm being overly paranoid about this, have a look behind the smoke head. It clearly states that these devices were manufactured in 2014 and need replacing no later than 2024. This recommendation is in place for a number of issues. Obviously, battery-powered devices will eventually drain down, but many homes still rely on outdated detectors, particularly mains-wired ones, under the false belief that they last indefinitely. However, these devices use the same technology as battery-operated alarms and degrade over time due to dust, insects, grease and nicotine, which can lead to false alarms or worse, failure to detect smoke. Building regulations mandated mains-wired smoke detectors in new homes from 1992, meaning properties built between 1992 and 2015 may require replacements if it hasn't already been done. Some homes even have detectors over 30 years old, making them unreliable. Corrosion, disconnected power supplies and faulty sensors are common issues in aging detectors. So the only way to guarantee a smoke detector will work is to replace its head every decade. Maybe it's something you should be checking on when carrying out periodic inspection and testing and recommending as a remedial measure. So with that in mind, I'm replacing the existing smokes in this house with these ones from the Cavius family of alarms from Kiddy. As you can see, they're a nice compact fitting, which is brilliant because the basic coverage of alarms as required for this type of property under building regs is LD3. This is where you just provide coverage to the primary escape routes, so the landing and hallway. This category of alarm just isn't going to cut it anymore and we need to add some extras. So because these smokes are so compact and I'm replacing older, larger units, I'm going to use this neat covering plate that hides all the mess left behind by the spark who installed them. So why do I need to add some detectors to my property? To answer that, we need to head into the loft, but first, to the roof. Since the house was built and the old fire detection installed, the house has had one serious modification, and that is these solar panels that have been installed on the garage and on the roof of the main house. These generate about 4 kilowatts of power on a sunny day. So not today. And because it was installed about 10 years ago and because it was the easiest thing to do at the time, the inverter for this array has been installed in the loft. Let's head up there now. But of course we're heading into a very dangerous space. Back in the early days of my electrical career, I'd have been dancing across the roof trusses in the dark without a second thought, but having seen some pretty nasty accidents in my time and taken a tumble or two myself, I'll be taking better precautions. The first thing is making sure there's sufficient light in the loft. I'm using these Kangastar 10K fittings from Night Searcher, which are just great because we can use a variety of batteries from different brands with them. This model, the A version, can accept batteries from Panasonic, Hikoki, Makita and Bosch. This one, the B, can take DeWalt, Milwaukee and Metabo. And there's an adapter, the C, which will connect these to Flex, Festool, Einl and Parkside. Each one gives off 10,000 lumens, so two of them will make this loft space better lit than Las Vegas. I'm going to use the hooks to hang this one from the handy wind bracing, and this one will sit on the deck. Speaking of the deck, this is the really dangerous part of working in a loft. The fact that there's only the trusses to stand on and work off, this could hardly be classed as a safe working platform, and so I'm going to use this cover-safe Spark working platform from Oxford's Safety Components, which are designed for this exact purpose. It folds up a bit like a garden trellis, so it's compact enough to get into the loft space, and then once up there, they can be extended outwards and laid flat on the fiberglass over the trusses, creating a safe working platform. They're made out of GRP, so they're lightweight for getting in and out of position, and it also makes them insulated, reducing the risk of shocks from faulty or broken electrical fittings or old wiring, possibly hidden in the thermal insulation here. Right, we're nice and safe. Let's have a look at this inverter. I'm mostly okay with it being in the loft. I mean, I am a little concerned about a 4 kilowatt inverter sitting on the wall directly above where I sleep, but at least it's not a battery, and it hasn't been an issue yet. However, since this was installed, the British Standards Institute have published this document, the PAS 63100, snappily entitled Electrical Installations Protection Against Fire of Battery Energy Storage Systems for Use in Dwellings. Now, we don't have a battery installation here. However, if you turn to chapter 7, you can see it concerns itself with power conversion equipment, or PCE. In the definitions section of the document, we see this is an electrical device converting one kind of electrical power from a voltage or current source into another kind of electrical power with respect to voltage, current and frequency. Then see the note. Examples include AC to DC converters, DC to AC converters, DC to DC charge controllers, and so on. So my newly inherited inverter falls into this category, and so therefore must comply with paragraph 7.2, protection against fire. It basically tells us that if PCE is installed in loft spaces, store cupboards or other infrequently visited locations, then you need to have a smoke detector / alarm installed in that location, which is interlinked to the system in the rest of the property. So in order to comply with PAS 63100 and add a layer of protection to this property, I'm going to need to install a smoke detector into the loft here and, notice, interlink it to the rest of the property. So let's just talk about that interlinking principle for a moment. The idea with interlinking alarms is that if one of them is triggered, it will start to sound an alarm, but it will also trigger all the other alarms it's connected to. So you can imagine that if this device in the loft is ever triggered, it might be quite hard for someone sitting in the lounge watching telly to hear. So they interlink, so that if one alarm sounds, they all sound. So the existing positions in the hallway and landing are interlinked with a third conductor in the cables bringing the power to them. That conductor is used as a signal wire to trigger the other alarm if one of them goes off. Now we're adding an alarm into the circuit, we've got options. Obviously from the landing it will be super easy to add another cable from the existing detector position and run it up through the loft to the new detector. But what if it wasn't so easy? Well, we could quite happily connect it off a local, regularly used lighting circuit and run the cable to the new position. It will have a permanent power supply, but if this inverter does go up in flames, how will it trigger the other alarms? Well, it can do so wirelessly via radio frequency, so it can be supplied by a different circuit but still trigger the other alarms in the event of a fire. And these are really competitively priced for a premium product in the radio frequency category. Clever stuff. In fact, I could dispense with the wiring altogether. It's easy enough in the loft to get the cable in, but let's just move to the kitchen. Why are we looking at installing detection in here? Well, this is a bit of a strange situation in this property. I've started by replacing the detectors because they're out of date. Then I've added a detector to the loft to cover the inverter up there. So I could finish there and call it a day. However, because I'm on a roll and also because I'm curious to know your opinion, I'm going to upgrade the detection to category LD2. Now, according to BS 5839-6, this property only needs to be an F2 LD3 system. But I've already gone a bit beyond that because of the one in the loft. So, in for a penny and all that, I'm going to install a heat detector into the kitchen and a smoke detector into the principal habitable room, which in this property is the lounge, turning the system into an LD2. Both of these rooms have challenges from a detector installation point of view. Trying to get cables from the existing smokes into here will be extremely difficult and require a lot of disruption, and the local lighting is looped at the switches, meaning I don't have a permanent line connection here at these, the world's worst light fittings. So instead, I'm going to install battery-powered detectors. This is acceptable because this is an existing owner-occupied property that hasn't been rewired or undergone material alteration, and therefore they could all be battery-powered instead of mains. And because these awesome little battery-powered detectors from Kidder are interlinkable via RF with the hardwired ones, triggering one of these will trigger them all. Brilliant! Now my property is properly protected and I won't have to change these again for a long time because they have a full 10-year warranty. Now there just remains the challenge of checking the smokes are operating correctly once a month by pressing the test button on here. Obviously with this one mounted on the ceiling in the hallway, it's really easy to do that. However, clambering up into the loft once a month makes it less likely that that will happen. So Cavius have produced a clever solution to this problem. It's this little device here, but for more information on this, check out this video right here. All that remains in this video is to say thank you very much for watching.